So in this example, we still need to solve the following quadratic equations. The first question is 2x squared plus 5x plus 2 is equal to 0. So we'll set up our little table. We have b is equal to 5. We have a times c is equal to 2 times 2, which is equal to 4. So we need two values that add together to make 5, and the same two values that times together to make 4. So let's have a look. If we do 1 plus 4 equals 5, and 1 times 4 equals 4. Okay, first one straight away. Now, this is where it becomes a little bit more tricky, because when we set up our brackets, that we're so used to just putting an x there, and then we can slip the numbers in, we actually have this 2 here that we need to focus on. So what we're able to do is, if we take a factor of 2 out of each part, then we're able to stick a 2 on the outside of the double brackets. So what this actually means that is, in the past, we've actually had a 1 in front of all the brackets, but obviously we just don't write the 1. Whereas in this case, because a is 2, we're going to have a 2 outside the brackets. So whatever's inside the bracket is going to be times by 2. So you can see straight away how we're going to get our 2x squared, because we're going to have 2 times x, which is going to give us 2x squared. The only problem is, if we put our numbers we found straight in there like this, so we have x plus 1 and x plus 4, when we expand that out, which I'll do now, we're going to get 2 times by, so I'll just do another set of brackets, x squared plus x plus 4x plus 4, yeah, which is okay. Then if we do 2 times, we'll just simplify, x squared plus 5x plus 4 is equal to 0. And then the final step, we just times everything by 2, just so we can get rid of this bracket. We'll have 2x squared, which is what we wanted, plus 10x plus 8 is equal to 0. But we wanted 5x plus 2, which obviously means there's an error here. And where the error comes from is the fact that we're not taking a factor of 2 out of our 1 and our 4 that we found, which means later on when we times them back by 2, we're actually just doubling the number. We're not actually undoing the work that we did earlier. And since we're doubling the number, we end up doubling the c value twice, which is why we get 8. And then we end up doubling the b number once, which is why we get 10. So let me show you what we actually needed to do. So I'll just rub out the workings here. So when a is greater than 1, we can't actually just put our values straight into our brackets. We have to actually divide it by the a value. So if we have 1 and 4, this means we're going to have 1 divided by 2, and we're going to have 4 divided by 2. So we're taking a factor of 2 out and putting it outside the bracket. So what that means is later, when we times it by 2 again, we'll end up with 2 times 1 over 2, which is 2 over 2, which equals 1. And we'll end up with 2 times 2, which is 4, which will give us the values that we actually wanted there in the first place. So let's give that a try then. So if we have x plus a half and x plus 2, then this means that when we expand it, we'll get 2 times by everything inside the bracket, just to make life easy. Then we have x squared plus half x plus 2x, and then obviously a half times 2 is a half of 2, which is 1. And then we times everything by the 2, so we get 2x squared plus 2 times 1 over 2x, which is 2 over 2x, which is just x. And then 2 times 2x, which is 4x. And then 2 times 1, which is 2, and that's all equal to 0. And then we'll just simplify that to get 2x squared plus 5x plus 2, which is exactly what we started with. So hopefully you can see why we do a times c is because we have to take a factor of a out of all the terms. And if I told you 2 separate methods, where one method we were just using c, but then suddenly when a is greater than 1 we have to use a times c, it's just another thing to remember. So it's always best practice to use a times c for all your questions, so that you never forget to do that step should a be greater than 1. So in this example then we still have x is equal to minus a half, or x is equal to minus 2. So that part stays the same, it's just that when we go to sub in the two values that we found that add up to b and times together to make a times c, we then have to divide them two values by a. So I have plenty of these examples just so we can get used to it. So the next one is 5x squared plus 19x minus 4. So set up our table. we've got b is equal to 19, we've got a times c is equal to 5 times minus 4, which is equal to minus 20. Then we need two things that add together to make 19, but the same two values need to times together to make minus 20. So if we start off with minus 1 plus 20 gives us 19, but minus 1 times 20 is equal to minus 20. So we got that solution quite quickly, and now we're working with x's, so we can set up our double brackets. And then since a is greater than 1, we need to place a 5 outside the bracket. So we have minus 1 divided by 5, and we have 20 divided by 5, which is 4. So then we can substitute minus 1 over 5, and then positive 4 inside the brackets. And let's just expand these so we can check that our answers are correct. So we have 5 times by, so we have x times x, which is x squared, then x times positive 4 is positive 4x, minus 1 over 5 times x is minus 1 over 5x, and then minus 1 over 5 times 4 is minus 4 over 5. Then we want to expand this bracket and times everything by 5, so we have 5 times x squared, which is 5x squared, 5 times minus 1 over 5x, which is just minus x, 5 times 4x, which is 20x, and 5 times minus 4 over 5, which is just minus 4. Then simplify this a little bit, we have 5x squared plus 19x minus 4 is equal to 0, which is what we started with, so we know our factorisation is correct. And then we just need to state what the two values of x are that make this equation valid. So in the first bracket we have minus 1 over 5, so we want x equals 1 over 5. And in the second bracket we have x plus 4, so we want x is equal to minus 4. So this means we have x is equal to 1 over 5 or x is equal to minus 4. So we move on to the next question. So we have 2x squared minus 11x plus 15 equals 0. So same again, sort our table out. We have b is equal to minus 11, and we have a times c is equal to 2 times 15, which is equal to 30. So in this case, b needs to be a minus number, but a times c needs to be a positive number. So there's obviously a minus involved, but the trouble is if there was one minus involved and we times that by a positive number, we will end up with a negative number. So that means that both values need to be negative. So we need a negative number plus a negative number to get 11. So let's do minus 1 plus minus 10 is equal minus 11. And then if we do minus 1 times minus 10, we get 10. So that's not the value we need. So let's try again. If we do minus 2 plus minus 9 equals minus 11, and minus 2 times minus 9 is equal to 18. So we don't want that one. Minus 3 plus minus 8 is equal to minus 11. Minus 3 times minus 8 is equal to positive 24, so we don't want that one. Minus 4 plus minus 7 is equal to minus 11. And minus 4 times minus 7 is equal to 28, and we don't want that one either. And minus 5 plus minus 6 is equal to minus 11. And minus 5 times minus 6 is equal to positive 30. So that's the one we want. So we've got minus 5 and minus 6. But since a is greater than 1, we need to do minus 5 divided by 2. And we need to do minus 6 divided by 2, which equals minus 3. So we can sort our brackets out. We've got 2 times x minus 5 over 2 times x minus 3 equals 0. Then if we're to expand those brackets to make sure we've done it right, we're going to have 2 times x, which is x squared, x times minus 3 is minus 3x, then we'll do minus 5 over 2 times x is minus 5 over 2x, and minus 5 over 2 times 3 is 15 over 2. And then we'll times everything by the 2 to expand the bracket. We'll get 2 times x squared is 2x squared, 2 times minus 5 over 2x is minus 5x, 2 times minus 3x is minus 6x, and then 2 times 15 over 2 equals 15. And then we'll simplify that, so we get 2x squared minus 11x plus 15 is equal to 0. And that's what we started off with, so we know our factorisation is correct. So next we just need to state the 2x values which make this equation true. So we have x minus 5 over 2 in a bracket, so we have x is equal to 5 over 2. Or we have x minus 3 in a bracket, so x is equal to 3, which are the two values that make this equation true. So we'll move on to the next example now. We have y squared minus 6y equals 27. With this one, the equation is not equal to 0, which is okay. We'll just need to make it into the form that we're used to. So we can notice that it's equal to 27. So if we take away 27 from both sides, we'll end up with y squared minus 6y minus 27 is equal to 0. So now we can approach this as we usually would. So if we create our table, we have b is equal to minus 6, and then we have a times c is equal to 1 times minus 27, which is equal to minus 27. And this is just a normal problem we're used to now. So we're going to have 1 plus minus 7, which is equal to minus 6. And if we do 1 times minus 7, we're going to get minus 7. Then if we do 2 plus minus 8 is equal to minus 6. And 2 times minus 8 is equal to minus 16. Next we have 3 plus minus 9, which equals minus 6, and this gives 3 times minus 9, which is equal to minus 27, so this is the one we want. Now we set up our double brackets. A is equal to 1 in this example, so we don't need to worry about placing anything outside the brackets. We'll just have 1 plus 3 and 1 minus 9 is equal to 0, and then we'll do a quick check to make sure that these are correct. We'll have y squared plus 3y minus 9y minus 27 is equal to 0, and this gives y squared minus 6y minus 27 is equal to 0, and this is the same as the equation after we subtracted minus 27 from both sides, so we know that our factorisation is correct. So we just have to state that y is equal to minus 3 or y is equal to 9. So the next example, we have w squared plus 2w is equal to 8. So same again, we just need to subtract 8 from both sides to make it w squared plus 2w minus 8 is equal to 0. And then we can set up our table where we have b is equal to 2, a times c is equal to 1 times minus 8, which just equals minus 8. Since a times c is a minus value, then we know that one of the values we need is a minus number. So if we start with minus 1 plus 3, this is going to equal 2. And then if we do minus 1 times 3, we're going to get minus 3, which is not what we want. Let's try minus 2 plus 4 is equal to 2. And minus 2 times 4 is equal to minus 8. So that's the one we want. So we've got minus 2 and 4. So we'll quickly set up our bracket. So we'll get w minus 2 times w plus 4 is equal to 0. And then we'll quickly expand that just to make sure we're correct. So we've got w squared minus 2w plus 4w minus 8 is equal to 0, which gives w squared plus 2w minus 8, which is equal to 0. So we know we've factorised correctly. We just need to state our values for w. So we have w is equal to 2 or w is equal to minus 4. So our last question before moving on to some exam style questions is we have y squared plus 9y plus 4 is equal to minus 7y minus 58. So it's very similar to the one above, but we just have two terms that we need to move to the left hand side of the equation. So we're going to have y squared plus 9 plus 7y plus 4 plus 58 is equal to 0. So I've just added 7y plus 58 to both sides, which makes the right hand side 0. And I'll just quickly simplify this, so we get y squared plus 16y plus 64 is equal to 0. And then we'll make up our table. We've got b is equal to 16, a times c is equal to 64. Then we need two numbers that add together to make 16, then times together to make 64. So I can sort of see straight away that 8 plus 8 is equal to 16, and 8 times 8 is equal to 64. So the two values we need are 8. Then if we have y plus 8 times y plus 8 is equal to 0. And then we'll just expand this to double check it. So we've got y squared plus 8y plus 8y plus 64 is equal to 0. So that gives us y squared plus 16y plus 64 is equal to 0. And obviously we know that our factorised version can just be written as y plus 8 all squared is equal to 0, because we're just going to have one value of y. And this is where y is equal to minus 8.